let's talk about fossil fuel formation. First off, what are fossil fuels? Let's talk about them. Coal, that's a type of fossil fuel. It's formed from fossilized organic material. Oil, that's or sometimes known as petroleum, also a fossil fuel. Natural gas. All three of these are considered non-renewable resources. Non-renewable is because once we take these out of the ground, that's it. They're not coming back. These things take millions of years to form. So we'll get into each of that. So we have coal, oil, sometimes known as petroleum, and natural gas. They actually can all three be somewhat related. It's basically they all form essentially the same way. You take organic material, plant material, stuff like that. It gets buried under sediment. Over time, that organic material gets compressed due to a little bit of heat, a little bit of pressure, and it changes into coal, oil, or natural gas. I want you to think, stick with me now, stick with this analogy. Depending on what you eat, organic material, it goes through different chemical processes in your body, and how it comes out the other side depends on a few things. Well, one, what you ate, and two, how's your tum-tum feeling that day? If you're a little bit of an upset stomach, so different conditions in your stomach, out the back end might be more liquid and gas. Whereas if it's functioning normally under different conditions, what comes out the back end might be a little bit more solid. Same thing here. So depending on the organic material and depending on the conditions, we can either get coal, oil, natural gas. So these are like the poops and farts of Earth, of the natural world, essentially. I know, I'm a high-quality instructor. So, coal is a solid fuel formed primarily from the remains of trees, ferns, these are small bushes, and other plant material preserved from about 280 million to 360 million years ago. So this stuff was made from decaying material, plant material that fell to the ground, was buried, and over 200 plus million years, heat and pressure altered to coal. So that's why it's a non-renewable resource. Once we take all that coal out, we would have to wait 300 million years for it to come back again. It's pretty much a non-renewable resource. One thing to note, charcoal is not coal. Charcoal that you use in your barbecue is usually charred sawdust and charred wood. This is coal, actual coal, organic material, 300 plus million years old that's been compressed to form this energy-rich fossil fuel. Different types of coal include lignite, subbituminous, bituminous, and anthracite. Lignite is the lowest grade of coal. Anthracite is the highest grade of coal. Lignite is only a little bit of heat and pressure. Anthracite, the most heat and pressure. So anthracite has the highest energy density. It's very compressed, very energy dense, very energy rich. So again, how it formed, typically plant material, even before the dinosaurs, giant plants died, oftentimes in swamps. That material fell to the bottom of the swamp, kind of just kept piling up, organic material piling up. In swamps, water doesn't really move around. So the dead plant material was just falling to the bottom, layering up, layering up, layering up. Over time, over millions of years, the plants were buried underwater, more dirt, etc. Heat and pressure turned all that material into coal. So eventually, with more heat and pressure, anthracite, just a little bit of heat and pressure, you get things like lignite. Peat is another form of fossil fuel that can be burnt. It's not necessarily coal per se, but it is material that can be burnt. But again, lignite, bituminous coal, anthracitic coal. So you can see the number of years needed to create this material, how it's created. So oftentimes the coal that we're using to burn to generate electricity is bituminous coal. There tends to be a lot of it. Anthracite coal is the target. There's just not a lot of it around. So that's the best, but it's just not a lot of it around. So a lot of what we utilize to burn and generate electricity is bituminous coal. It's pretty good. Not as good as anthracite, but it's pretty good for what it is. When we're looking around the world, we talk about coal reserves. Reserves are large deposits that, based on geological surveys, engineering studies, drilling, tests of different areas. So reserves are what's thought to exist to a very, very high degree of certainty. So a reserve is what we think we got. All right. Looking around the world as far as coal reserves, the total amount of coal reserves, so in total, the U.S. actually has the highest amount of coal reserves, we think. So the U.S. has 24% of the world's coal still underground, we think. Russia, number 2, Australia, China. So we still think we have a lot of coal. That's why we're kind of beholden to coal in this country. Why we're still using it for electricity, because we have a lot of it. When we burn it, it creates pollution, bad for the environment. Well, that's neither here nor there. It's just, we have a lot of this source. This is why so many power plants, electricity generating power plants, utilize coal, especially on the East Coast. So the major coal deposits of the world, orange is that anthracite and bituminous. That's the coal which we're looking for. Lignite, very low grade coal. Can't really do too much of it. You can burn it, but as far as a good energy source, it's not the best. So the orange is what we're looking at. So the U.S., you can see Russia, Australia, China, some decent coal deposits. Again, focusing on the U.S., the green, anthracite and semi-anthracite, almost anthracite. That's what we're looking for. Not a lot of it. All right, Pennsylvania, West Virginia, Kentucky, maybe a little bit in Washington. That's what we're targeting. There's just not a lot of it. More so, it's the bituminous coal, the reds and the yellows, the bituminous coal. The blue and the orange are sub-bituminous coal, and lignite, lower energy density, can't do much of it. So it's kind of these yellow, red, and green that we're looking for. So these are where the reserves are. Again, that's the stuff we think we have underground, not yet mined. So coal has advantages and disadvantages. It's very energy dense. There's a lot of energy compacted into that coal. It's plentiful. At least in the U.S., we got a lot of it. It's easy to exploit by surface mining. You can also use subsurface mining, but there is a decent amount of coal that can be gathered from surface mining. Think back to last year, strip mining, mountaintop removal. These are all surface mining techniques. It needs very little refining. You basically take it and burn it for what it is to generate heat, to generate electricity. More on that later. And it's relatively inexpensive. It's easy to handle. It's easy to transport. You dig it out, you put it on a train, you send it someplace to be burned. The disadvantages is that it contains impurities, and when you burn coal, it releases those impurities into the air. So we're talking pollution, carbon dioxide, etc. It also contains trace elements like mercury, lead, and arsenic, which are poisonous. So when you're burning this material, not only are you releasing carbon dioxide and impurities, you're releasing poison into the atmosphere as well. And by burning all this, again, it increases levels of air pollution. When you burn the coal, ash is left behind. You got to dump that somewhere. Again, carbon is released into the atmosphere, adding to climate change, global warming. Advantages, disadvantages. I know where I personally stand on this, and this is one reason why coal is really dropping off in the U.S. as far as and around the world. A lot of talks about climate change go into reducing how much coal is being burnt. But if you're a country that has a lot of it and you can make money off of it, well, you want coal to be burned because you want to make money. So remember, different types of mining, surface mining, can get at coal. This is mountaintop removal. You can see a lot of these mountaintops have just been flattened off. There you go. So there are environmental issues to think about when mining coal. To show you, how big this area is, if you look at this little yellow thing in this circle right here, that's one of these giant mega haulers compared to SUV. So here's one here. Here's a few more all over here. So these are large areas that are being destroyed. Typically, what coal is used for is at coal-fired power plants. This is actually, or was, I should say, the Navajo Generating Station in northeastern Arizona. It was the largest coal power plant west of the Mississippi, but it was shut down in November of 2019. Again, the U.S. is trying to reduce its use of coal, so this is one of those electricity generating power plants that was closed. Essentially, how it works is you got coal, essentially here, you bring it into the plant, and you burn it, all right? So you bring the coal in, you crush it up, you pulverize it, you burn it, so to generate heat. You have pipes of water that are flowing through these boilers in which you use the heat to heat up water. That water turns to steam. Steam goes through pipes to spin something called a turbine. That's what these are, these kind of fan blades. So it spins a turbine. A turbine is connected to a generator, so it spins a generator to generate electricity. I'm not going to get into how a generator works, but essentially you spin it. You need to spin a generator to generate electricity. So in an effort to generate electricity, we just need something to spin a generator. And in this case, for coal-fired power plants, again, you burn it to heat up water. Water turns to steam, goes through the pipes, spins the turbine, which is connected to a generator. So you spin the turbine, you spin these fan blades to spin the generator. Generator generates electricity. So that's essentially how all electricity is generated. The water used is somewhat recycled. That steam is condensed, and that hot water is sent off to kind of cooling towers, which you can actually see out here in the distance. So any water that's used is sent out here into these big containers to cool off, and then they take that cooled now water to bring it back and recycle that. So you also need a lot of water. You do lose some water in this process. So again, you can kind of see, not only do we need coal for a coal-fired power plant, but we need water. We need water as well, which in the desert is a dwindling resource. So that's how so the energy within coal, that's how we utilize it most often to generate electricity. Now again, when you're burning coal, you get a lot of CO2 emissions as well as those other impurities. But do you need electricity or do we need an environment? But you have to have an environment first to utilize electricity. So again, I know where my opinions stand on this, but it's something as a country, each country needs to think about. Where in the U.S. we're decreasing our number of coal power plants. In, for instance, China and India, they're using more of them. They have coal, and they're typically a cheaper plant to create. If you look at it, it's not too much. Essentially, you just got to burn stuff to heat up water to spin a fan. There's more to it than that, but in essence, that's what it is. So there's, not too much craziness that goes involved in generating electricity by burning coal. Recently, as well, you don't hear about it too much anymore. You might hear about it a little bit on the assignment, but something called clean coal. There's no such thing as clean coal. That's just a fancy term someone came up with to make you think that coal is clean. It's not at all. Whether it's lignite or anthracite. Anthracite, again, a little more energy dense. So when you burn it, it burns hotter. It burns longer, so you can create more steam, which means faster spinning of the turbine, which means more electricity being generated. That's why you want anthracite. Or bituminous coal, whereas subbituminous or lignite, when you burn it, it doesn't burn as hot, it doesn't burn as long, you're not generating as much steam, so that means the turbine isn't spinning as much, meaning the generator is not spinning as much, meaning you're not generating as much electricity. Excuse me. So, that's the goal of oftentimes energy resources is generating electricity. How do we do that? You'll see kind of similar themes as we go through each energy source. So what we'll do, that's coal. All right, that's coal. So what we'll do, we'll pause here. When we come back, we'll talk about oil, petroleum, another non-renewable fossil fuel. See you back here in just a second.